Awesome. Hello. I should have known they asked to share maybe fun facts about you, things like that. I did not do that. I didn't question why no one asked me. Should have known Brian was going to talk about me like that. But I'm super excited to be here. You mentioned I also work at Capital One. Outside of work, I do a lot of stuff as community in tech. I find it super fun. I used to lead the, is this too loud?
No, it's good.
Okay, perfect, awesome. I used to be one of the leaders for Women Who Code down here in DC, and now in New York I do a lot of stuff with Women Who Go, so I find it super fun. And outside of that, I've actually picked up a new hobby in the past couple of months. I've started to learn Italian. I visited over the last summer, and it's like a fun language, but also realistically, I have some relatives that only speak Italian. I met them, it was really awkward, so I was like, all right, I'll try learning this for the next time we meet. And since then, I've been kind of thinking about how learning a spoken language compares to learning a programming language. So when we learn a new spoken language, there's actually a lot of research out about how having that comparison between the language you know, like English, and the language you want to learn, Italian, is really useful. There's really cool pieces of research that actually gets you to think about the world around you differently. This is debated between social scientists and linguists, but what linguists say is because the language is different, you'll kind of think about problems in a new way. So for example, Russian speakers are faster at distinguishing colors of blue than English speakers because their claim is they have more words defining blue. Japanese speakers will, if you give them a group of objects and tell them, hey, make piles of them, they will sort them by material, not by the shape, like English speakers will, because material is more defined word for them, or language for them. And Koreans will also group the objects by how they fit together, which is super cool. That's like a very physical way of trying to group these things that I find fun. So with that in mind, I was kind of wondering how might that compare in languages. In the past, as I was picking up something new and somebody expressed something to me in terms of this is what you knew before in, say, C, this is how it works in Java, I found that really useful, so that's what we're going to be doing today. I put together a couple of small examples, running through it in Go, and then showing you in other languages that either are similar or not as similar, just to kind of get that conversation going. All right, so we're starting with the first generic Hello World API. Brian showed basically maybe exactly the same thing. I was standing in the back and I have bad vision, so I couldn't quite tell. But this is the Hello World. It does as you would expect. It takes in a request and returns a response. If you haven't written it before or you're new to APIs for whatever reason, the listen and serve is what will set up your port, tell you what to talk to, and then pass in the default serve bus. My first slide had an anonymous function, so it was just calling the handler func right in the code, but if you want to separate it out, that generally is what you do with a larger application, and this is the handler that would do it. It essentially is taking in whatever the client sends you in the request and then responding to that in the response writer. So whatever you print to what is W on the screen is what the client will see. Now, this is really all that you need for an API. If you're a new developer, that's pretty exciting, but even if you're coming from a more verbose language, it's actually really awesome too. Most of my background have been in embedded systems for like doing C and C++ in the government. And if somebody asked me to do like a website or a web service, I was just like, that sounds cool. I can JTAG your like embedded systems on your like boards here, but I have no idea what you're talking about in this space. Eventually I started to learn. I would do it in different languages, make web services. But when I came to C, or Go, when I came to Go, it really felt like, not when I came to C. When I came to Go, it really felt like the language I had always wished I had started with, or I had always had with me, because it just sort of answered long-going questions that I had just by being as simple as this. So, we have the Go version. The point of this talk is not to language shame anything else, it's really just to draw comparisons and contrasts, but we'll see how we do. All right, the first example is pretty similar. This is a Node API. It's actually like awesomely similar. I've been learning Node after Go, and it's like JavaScript before was very foreign to me, but surprisingly not as hard now. So yeah, you have it in here, you create a server, you get in the request from the client, and you respond. The next request, this one actually really excites me. It's called Spark. It's a web framework in Java. I'm not sure who has seen it or not. I saw it a year or two ago, and it's in one line of code. You have your GET request, it has an API, it has the response, it has the request. I have written a good amount of Java web servers before, and they looked absolutely nothing like this. So when I saw it, I was very thrilled. And in fact, the Java community as a whole is moving more towards this, let's be clearer about the request and response. Spring 5 that's coming out, and Java 1.9, and Kotlin even are actually getting really close to this, like, hey, how can we simplify these requests? All right, so let's add in a little bit of functionality. We want to get in a parameter that somebody is calling from the API. This is the struct in Go. It just has the name and it has an ID if you want to have a global variable counting. The handler changes a bit. You now have in the request, you're going to start reading and parsing the form of what they send you with parse form. What that does is it puts all of the query parameters that the client sent over into a map. You can then search that with form value, with whatever the name is. Here it's actually called name, which is then saving that into the struct, and you can use it for however you want. If you wanted to check in the whole body, if the client sent that in, you can also use parse form, and you'll read that in a map format as well. Now, let's compare this with Java Spring, not Spark. We're going to start with, here is a model of hello, and it's a resource representation class, but it's relatively similar, at least to me. You have your ID, you have your name, compared to the struct, you can kind of draw the comparison. Now, this is with Spring 4, so this is their hello controller. If you're not familiar with Java, or maybe not with Spring 4, this might look different, but it's kind of fun. They have this new request controller annotation, and it makes things a lot easier. Instead of having the standard MVC model, you actually just have a web service controller that doesn't require this like viewer technology to handle all the server-side rendering. That simplifies things a lot. So you can make this request. The request controller currently is taking any HTTP verb. You can absolutely cut that down to only accept GET requests. And then inside of it, the other kind of important part is the request param annotation. So that's what actually binds the information coming from your client to the hello object, which then creates that for you to use in other places. The other cool thing that I was looking at with Java now is Spring has this whole HTTP message converter support that takes this object that you have, converts it right into JSON. A lot less lines of code than things that I had been doing previously. The last thing I wanted to bring up was the build in Java. This is still obviously quite different from Go, but getting cooler as we go along. So you don't have to do it through a war. You can actually run an executable with Gradle, with Maven, whatever you might want to use. The interesting part on this slide is the Spring Boot application. There's kind of a lot going on in that actual annotation, so I won't go into all of the details, and it does sort of point out what's really nice about Go is the fact that you don't have to understand like 15 things that just happened with this one annotation, but it handles a lot of the configuration and also will do the component scan to tell you, hey, this client information is going into the hello object. Okay, so now we're going to look at reading from the actual request of a body. I mentioned you could do it with parse form. You can also do it with a JSON decoder. And this reads in the JSON body and then stores it into hello. In this example, that's literally all that it's doing. Ideally, you probably actually do something with that data, maybe store it in a database or manipulate it and send it back to the user, but this is your example. If we compare it with Express, it's also quite similar, again, to kind of draw these comparisons. We have the hello schema. My picture's really small on here. And that creates the name struct, and then you get in your request, you start the post, read the response right to it, it's on the server, very, very similar. And since I showed that last example, it had Express involved with it too. So if you haven't had time yet to look into HTTP routers in Go, they're a ton of fun. Totally recommend it, and there's a lot of them. The one that I'm showing right now is Gorilla Mux. I decided on it just because it's, I think, the most popular still. It's been around for a while, and no matter what framework you use, they almost always compare back with Gorilla Mux, so it seems like a pretty good one to at least have experience with. But you can see in here, so you create a router, and then you add in all of these requests and start the server. Awesome. Comparing with Express, you can see it has the general same flow. You import Express, that's not required, you can make your request. Something that I wanted to mention, basically every time I start a new project, at least for myself, I try out a different router, because they are actually pretty fun. But there is one that I've really liked previously, and it's called Ozo Framework, and it's actually even more similar to Express. I was playing with Azo and using it for a couple of projects, and then looked at Express and realized I actually felt very comfortable with the framework. So if you're kind of if you're coming from that sort of background, that could be a cool tool for you. All right, so the last thing that we're going to do is show some examples of storing your data, because that's probably important for you at work. So in Go, Brian mentioned, this all comes down to the database SQL package. You can have different drivers, but they're going to be anonymous, so that way you aren't exporting public functions from your driver that you don't want to, and if you switch out your driver later, you're not going to have like a ton of, hopefully, you will not have a ton of code to change. Underneath it, the driver will register itself as being available to the database, and then you can start using it. So you have SQL.open, and what that does is it takes in the driver name, and then the specific driver string telling you what exactly you're connecting to. In this case, MySQL with a hello named database. And that's like a lot of it. Some tips for there is, of course, check your errors. Brian mentioned this. Coming from other languages, it felt weird at first because it seems kind of verbose to have this if error does not equal nil all over the place, but you get used to it and it saves you like quickly. So if you don't use them, you'll understand why soon enough. And finally, the tip that I had was to make sure you're adding in defer database.close. Even if you're using especially if you're using multiple databases, I've seen some code where you're talking to one database, you open it, get some data, close it, open another, start getting data in from there, and you kind of flip back and forth. That can get messy very quickly. And maybe that's because you forgot to close something, or you're just not thinking through all of it, but that can lead to a lot of memory allocation errors. So just a tip to remember is to defer that close. My comparison here is with Python. Python is literally right on the line. That's unfortunate. But it's very simple in there. That's part of the reason. So it's just taking in the server, the database name, password, very similar in the connect line to Go. But now we're going to start getting the data. So in Go, you'll start with a query generally. If you want to actually get rows and start parsing through them, you use a query. If you don't, use exec. And the other tip here is around defer rows.close. You can close your rows after every time you access it if you're going through all of them, but it's still awesome to do the defer immediately. That way you don't run into any panics at the end if you escape out of the loop. I've done that before, or anything along those lines. You'll iterate through it with rows.next, and then in scan, that's where you actually get the data. Last tip, again, is just to check for errors. In Python, a little bit differently is you can create a cursor object, and that will execute your queries. Something in Go, when you start SQL.open, you're not actually connecting to the database then. You're allocating a resource to connect to it later, so it has kind of a lazy loading of that database, which happens when you construct the first query. So that's just something to know if you're actually worried about the allocation or thinking through your project structure. The other thing with Python, not a ton is different, but it's just fetch all instead of rows.next. And that'll start looping through, and you can check all your applications there. All right, so these are just some of the examples that I have. I actually made like a lot of examples on my computer, and then wasn't sure how many would get boring, and some of them are kind of long. But I think it could be fun. It was at least fun for me. There's like examples with cat pictures or Ron Swanson quotes or logging, if you find that fun. So I would love feedback around if you found this interesting, if you have ideas, maybe while I was talking you were like, I would love to see examples in these certain areas, or I know examples that I could help with because I'm really good with Ruby, etc. I would love to talk to you about that. It could potentially be a pretty cool community project is what I'm thinking, because of course, if I'm coming from a C background to Go and there's a resource with like, hey, these are Go idioms and these are maybe what you've seen in C before, that would be fantastic and really helpful. But honestly, even if you're just coming from a Go background and you can look at these other languages and make comparisons, it can really help with why does Go do the things that it does. It can help with establishing what these best practices are, and probably just be a lot of fun. So I'd love to work on that. Find me after if you have any questions. Thank you. I don't know if my hair's all over the place. Any questions? Or you can,
There is a website out there that does language comparisons.
Yes.
I don't remember what it is, but it sounds just like what you're looking for.
Yeah, it's similar and awesome. I forget, the name's kind of funny. And it does it by performance, which is awesome and like absolutely what I like for certain uses. But I would love to see it around specifically just like, hey, this is how we do it in Go. These might not be the fastest examples, and these might not be the best examples, but they might be the actual examples you've seen written, and like use that to kind of compare. But super additive, like those would be helpful together.
Surprising sort of lesson or pattern that you found between multiple languages when you were looking through this?
Well, so Java just makes me happy because for a long time Java freaked me out. Like when I started writing it, it was just really overwhelming and long and verbose. And I was like, why is this like web XML? Oh, I don't think I mentioned there was no web XML in any of the Java that I was showing, and I wouldn't understand how data was getting passed a lot of times in projects. So I was sort of expecting that when I was doing the comparison, but as I started to look at the newer Java, it was much simplified, and that made me really happy. We can definitely talk more after. But yeah.
The website that I always use when I'm picking up new languages, it's called Rosetta Code, after the Rosetta Stone, and it has Go, and that's actually between Go by example and Rosetta Code. That's how I was able to translate what I previously knew into Go.
And if more people have suggestions on sites, definitely come find me because I will write them down and I'll probably just add them at the end of this slide. All right, so, thank you again.